I'm very excited to welcome to the stage Joshua McDougall. He is an associate managing director with Kroll's Cyber Risk here in Denver. He's the co-author of the Cryptocurrency Security Standard. He's a C4 board member and a BTC 2019 conference organizer, so he helped put this together. And he specializes in investigations involving complex data systems, including blockchain-based systems and assets. Please welcome Joshua McDougall.
Thank you very much, Stephanie. Thank you all for coming. So, luckily that slide's already done. A little bit of housekeeping. I normally don't drink coffee before a presentation, and I forgot that all day, so I apologize. Second of all, if at any point you need some of the supplies, please come up and get them. We have too much. We have paper, we have pens, way more bags, etc. Finally, this is probably the most interactive session I've ever given, and way more of you came than I expected. So we're going to try and keep timing good, but that mixed with the whole coffee situation, bear with me. I think we're going to have fun, hopefully. We'll see what happens. At the very least, we can have a sick poker game, or actually maybe some D&D later, depending on what everyone wants. So, key ceremonies. Why are we doing this? What's with the pageantry? Why have I handed out way too many objects and gave Amazon way too much money in order to pull this off? Well, regardless if we're individuals or if we're working on behalf of the organizations we work for, no matter what, we have to be able to create keys that are complex enough to be safe for us, but we have to do it in a way that can be defensible, but also not necessarily repeatable. So a key ceremony is generally just a process, and believe me, this isn't the official key ceremony that you have to follow every single time. But it's a process in which we're going to dictate how we run it, we're going to get some ideas involved, and then follow those and hopefully know that at the end of it, we can sleep well knowing that we've got these keys safe. So, there's a list of all the reasons why we would want to use private keys. I'm sure there's more reasons why we would want to use private keys. If we're here today, it's probably because we want to secure cryptocurrency assets. But there's many reasons why we would want keys. So I'm not necessarily going to get into that. Now, where do we start? Well, clearly, based on the fun session we just had, first we accessorize. Accessorizing is important. Oh, I've given out most of what I had. There we go. So, of course, we got some dice to start. Just your classic six-sided dice. Now, I won't necessarily say what. In a real key ceremony, you will likely use some dice. I would highly recommend it. You don't have to use it. Again, this isn't telling you exactly how to do a key ceremony. This is showing you why you would use certain elements in a key ceremony. But your dice, classic element, something you can trust, something you can pretty easily verify, and you can verify it just by rolling it. Now, I do suggest clear, though, because clear you can at least look in. If this was a loaded dice, maybe you could see a little weight in there. You don't necessarily know, though. Now, the other thing we've got, several decks of playing cards. Playing cards are amazing because the quantity of playing cards in here means if I shuffle a deck, and I shuffle it good, assuming that it's not like a brand new deck and it's already ordered and things like that, it's assumed that no two shuffled decks have ever been the same. That's how many possibilities there are when shuffling a deck, which is a little bit absurd, but it makes it perfect for what we're doing, which is creating something that's a big secret. Now, I've also given out some tamper-evident bags. Now, notice I say tamper-evident bags. It's common to say tamper-proof. There's nothing tamper-proof about that. You can get in it. Absolutely nothing is going to stop you from getting in that. It's a bag. But the secret of the bag is that you know when someone has gotten in it. And that tends to be really important, too, for obvious reasons, or not. I'm going to suggest having a laptop. Normally, a laptop, and I'm going to get into that, would be a little bit customized for this situation. The keys we're generating today should not be keys you use, please. We'll get into more of that later. And then we got some paper and carrots, or pens. I'm not a very good artist. I tried to make a pen. I think it's a pen. I don't know. Anyways, because we're going to want to write things down. We're going to want to back things up. Admittedly, there's things that aren't necessarily on here. There's the great crypto like backup devices that the one organization was showing off in the vendor area. Those would be amazing to have in a key ceremony, but we don't have time to sit here and etch keys, so we'll kind of skip those for today. So, moving on to a key ceremony, what are we actually preparing to do here? We want to know, going into it, what is this for? It could be for yourself. It could be something as simple as, I got this sweet new keep key at this kick-ass conference, and I want to create a key that I can put on it. But when I create that key, I want to make sure I create a good backup, and then I put that backup somewhere, and that key I create is really nice and strong, and then I put it on the device, and I'm confident. So if anything happens to my device, I have my backup, but I also know that the key I put on the device is excellent. Or it could be an organization. Maybe it's a custody service, and you want to make sure that you're creating keys that, maybe even you want to make it so your employees don't actually know the entire key. Maybe you want to make it so it's going to take several of your employees coming together to bring that official key back together. And it's a key that you touch like maybe once a month or something like that at most. Or maybe your team is coming together to create a hot wallet, or to create a key that's going onto your hot wallet later on. And you still want to know that key was created in a very secure manner. You still want to know that it was backed up in a way that you're comfortable with. But it's certainly a much different experience than the individual. So that's fine. There's a number of reasons a number of things you should be asking yourself going into it, but overall it doesn't super change the pageantry of it all. So we'll continue on. Now I mentioned a computer. A computer is one element of that trusted systems that we need to set up. If you're going, let's say, hardcore, I don't use the term paranoid here because I don't think it's being paranoid. I think it's being cautious. If you're going cautious here, you're going to want to have a machine potentially even dedicated to this process. Something that you've ripped out all the wireless from. There's no Wi-Fi, there's no Bluetooth. Some even would want to rip out the sound. No microphone, no speakers. Anything that you can use to communicate other than the screen in and out, you might want to remove from this device. Because what you're trying to do is you're trying to limit the external influence that can come in during that process. Be it human influence coming in from a coworker beside you, or someone from outside the building trying to influence that, or trying to set something up leading up to it to influence it. I don't know who would do that. That would be absolutely awful. That said, I do have some prizes. So anytime someone wants to yell out and point out that I'm stupid, please. It might be a sick trick. And then we're trying to clean up the process afterwards. We want to make sure that whatever we do, again, we want to make sure what we're doing is defensible. But we want to make sure that it can't be repeated. Because if let's say, okay, we want to make sure there's a video camera in the room. We want to make sure the room is videotaped, that way we can see everyone working. We know that they're not typing anything that we don't expect them to on the computer. We can see that they're properly rolling the dice. We can see that they're using the card decks properly. Now that videotape is basically your private key. So I hope it might not be a bad idea to record that videotape, but if you have procedures in which you want to back up that key, your videotape should actually be treated the exact same way as that key, because you've given it enough evidence within that videotape that it could actually be used to recreate the key. We'll get into more of that a bit later. Now, there is also all sorts of other fun stuff like Faraday cages, which reject Wi-Fi or reject wireless signals. Even strategic purchasing, strategic procurement. If you need that laptop and you order it from Apple, and you ordered it with your name and you're super paranoid, it's possible that shipment can get intercepted and altered in the process, and then suddenly it shows up at your door and you have no idea. So it's pretty common for businesses to go out and just walk into the most random store that they can feel, although random's a bit of a loose term in this one, just grab a machine off the shelf and then walk out. So there's a lot of different strategy. Crap, apparently my time's up already. Can we get a real timer? Because otherwise I'm going over. So quickly before we move forward, and I swear it'll get fun soon. Right now it's just Josh talking, white text, blah. Hashing, does anyone know what hashing is? Hashing? Most of you? Okay, cool, but not everyone, so I will go over it. Hashing is a one-way function, which means if I have some sort of text and I put it through this hashing algorithm, then I get some completely other text. Now, theoretically, the exact same text will always produce the exact same result. But even changing it one little character, as you can see that period is added, changes the results completely. It doesn't change a portion of the results, it changes the entire results. We will see hashing in practice as we go through this, so I just want to make sure everyone appreciates what's going on here. We can even throw way more text at that hashing function, but the result is always boiled down, in this case, to the same 256 byte string. So that's what we'll likely be doing. What we're gonna do is we're gonna create some entropy, and then we're gonna hash that entropy into a 256 byte string, and then we're gonna create a private key out of it. And after that, we're gonna create multi-sig wallets together. It's gonna be super exciting. So what I would love everyone to do is to go to that, ceremony.guide. It's a website. I'm gonna be following along with you. Should be a lot of fun. It will work on mobile, not great, but it'll do a pretty good job. As people are getting out their laptops and going over to Ceremony Guide to follow along, that QR code will bring that up automatically for you if you trust scanning a QR code. The one device I haven't talked too much about yet is this little thing on the left corner here called True RNG. This is just one example. Consider it like me calling it Kleenex here. Computers are awful at random, and I'll show why in a little bit. Humans are also awful at random. Random to a human is ASDF 1234. That's us thinking that we're being random. Computers are equally terrible at it, because computers only do what we tell them to do. So there's little devices that actually try and produce legitimately random things based on environmental factors and different things going on. Consider it like a gyroscope in your phone and rolling that around, but instead using electrons. Of course, we've got some other fun ones. I'd just like to point out, also at the top left, that was an actual piece of code, basically, and I think it was the PlayStation 3 that had a problem with random, where someone actually there was a variable called random, and its result was set to 4. So as, someone rolled a dice, it came up as 4, they're like, well, that's the random value. It's good. Great. So, time for me to follow along too. Let's switch over to some sort of web browser. Man, this is gonna be fun. Do you ever hate typing when people are looking? How about 56 people? Great. So, that still shows the presentation. Excellent. Come on. I know how to use computers, I promise. Yay. Excellent. Okay. So, it has natural scroll. It's gonna be awful. So, what we're doing here is, again, we're gonna create some entropy. This is what all these fun crap I've set into out is. And we're gonna take that entropy, put it all together, and make a private key out of it. Now, first what I'd like to do is I'd like to start with dice. We're gonna assume the only entropy we're using to create this private key is dice. That's it. And we're gonna do one roll. So I'd like everyone in the room roll one dice. I got 1. I'm gonna enable dice on my little checkbox here. I'm gonna type in 1. I'm gonna scroll the wrong way the entire day. I'm gonna go down here, I'm gonna hit generate key. Now right now what should be showing is entropy. The only entropy we've given this system is 1. That's it, in my case. If you rolled 3, you should probably type 3 there, and you should probably see 3. Now switch over and click seed. Oh, that looks random. That looks extremely random. No one could have ever possibly generated that as well. Did anyone else roll 1? Does that look familiar to you at all? A lot of heads rolling. Okay, who rolled 2? What does yours start with, sir? D4735. Everyone who rolled 2, does that sound familiar? Also a lot of heads nodding. All right. So there's a big difference here. That looks random to us. But what we've put in isn't strong enough. It looks random because what we did was we hashed that 1 and we got this big unique number. The only thing that will ever get that number is 1. But we all rolled, at least once, theoretically, 1/6 of us rolled 1 and got the exact same key. Now, to really push this point home, one time there was a wallet, we'll call it lockchain.minfo. They know what happened. And they were getting issues where customers were reporting, hey, I'm opening up the wallet for the first time, and I'm seeing I've got 6 Bitcoin. This thing's awesome. Other people are like, hey, I'm opening my wallet up for the 19th time, and I'm seeing I have no Bitcoin. This thing's awful. And they were, honestly, the company was freaking out, obviously, because this should not be happening. And they started narrowing it down. They said, oh, okay. It's Android wallets is only affected. It's certain Android wallets. And they looked into it deeper and deeper and deeper. And the operating system, the Android operating system itself, instead of returning very successful ranges of numbers, it was returning between about a 1 and 100, let's say. So every 100 users who started the wallet, it created a new wallet, and it's like this entire room rolled 1 together and all had the exact same wallets. So this has been an issue in cryptocurrencies. It continues to be an issue in cryptocurrencies. So choosing strong entropy becomes really important. So let's disable dice for a bit. And let's start entering some cards. So how do you enter cards? That seems absurd, I'm sure. Luckily, most of what I do is absurd, and it's fine. So I'd like everyone to take out your cards. Ugh. All right, so I'm going to start entering my cards, which would be Ace of Spades, 2 of Spades, 3 of Spades. You know what? I might have skipped a step. Looking at it, I think I should have shuffled, which brings us back to another step. Always make sure you prepare your environment properly. No matter what, even if these didn't look shuffled, how do I know someone hasn't put them in a very strategic order? If I don't shuffle it, then I'll never know. But if I shuffle it, I might create something that is seriously the most unique shuffling that will ever happen for me. So great. How many cards? As many as you want. Generally, if I'm doing this for real, if I'm rolling dice, I'm rolling 6 dice 5 times. And I'm just entering all those numbers in. When I'm adding cards in, I'm probably doing 2 sets of cards. Which brings us back to, sometimes if you're doing this as a group, let's say for an organization, you might have one person do one set, the next person do the other set, because you're not necessarily verifying that they're saying the card that they believe they're saying, or that they see that they should be saying. So if you go 2, now you're removing that human element out of it. Now, I'm shuffling. I'd like someone to tell me what I haven't done.
Turn around.
Lady in. All excellent points, especially I have not validated that 1, this is the right number of cards. And 2, I haven't validated that despite being the right number of cards, it's actually a right set of cards. So you will win a t-shirt whenever you want to come up and grab one, but no rush. Now, how many people have checked their cards? Excellent. How many people are happy with their deck? Okay. We have at least one upset person in the front. So, sometimes mistakes happen. Maybe you're tired while you're doing this and you check, and maybe you're happy with your deck and you shouldn't be. Maybe there's another problem in there. Again, this is with entropy, anytime there's a weak link, it's drastically reducing our ability to create a strong key. But that said, it's also why we keep layering different entropies on there. If there's something wrong with our deck and we missed it, well, at least we have the other items in there. If there's something wrong with our dice, if there's a loaded dice, well, at least we have these decks of cards as well. So limiting yourself to one source of entropy can be a problem. And honestly, hardware wallets and phone wallets, they all have the option there to just generate some random, and it's probably good. It's probably literally certifiably as random as it needs to be. But it's only one source. And if months down the road, years down the road, we realize that there was a problem with it, then we're potentially put in a bad spot. I mean, hopefully by that time, we still haven't solved the scaling debate. So at least they can't steal things fast, but we have to assume we have solved the scaling debate and they can steal things fast at that point. Now, those are the physical ones, and it's fun to do. I like it, at least. I'm gonna leave my dice in there, because why not? But now system status. So again, we use our computers every day. They give us random numbers all the time. What do you mean I can't trust this? How does my system actually generate random? What is going on in that process? Well, when your system generates random, it's not just choosing a random number. The computers don't have the ability to do that. Maybe one day they will, or they're specially designed to. They might have some functionality. But computers, what they do is they actually just take details from all over the operating system. They say, okay, what's the CPU at? What's RAM usage today? What's happening on the keyboard? What's the heat of the computer? What's the heat of the motherboard? What's the heat of the CPU? What's the network traffic going by back and forth? And theoretically, if we bring all of these details together, hash that, then we should get something really unique. But if we're specifically building a device and we're ripping out the network, and all the device is doing is generating a key quietly, and we're not playing any music from it, and we're not really doing a lot of typing onto it, aside from our cards, then what does this actually look like instead of this? Well, if we choose realistic, we're gonna get a much more realistic idea of what's going on. So instead of 0 to 100% times 3, we actually have 65 to 80% CPU. We've got maybe 7 to 10% RAM all the time, and we've got no network. We literally ripped the network card out. That's the whole point of this machine, is that it doesn't talk to anything. So if I'm a malicious person and I know you've created a key using your system's entropy, I know a much more specific set of boundaries that I can utilize to then run through. Theoretically, if I'm trying to guess your key, and I know that you've got 0 to 100 on all these, it's exponentially harder for me to try and crack all those possible options. But if I can limit that to these little slivers of details, rather than days or rather than years or decades or centuries, it could possibly be a year, it could possibly be months, maybe even days. It's tough to say. You don't know how much computing power your enemy has and how interesting your assets are. They could also be doing this and just hoping. They might not be targeting you. They might be targeting anyone who used this system. So they don't necessarily want to find your key. They want to find anyone's key. And again, if they know that theoretically everyone has these same likely limitations on that entropy, then it drastically reduces that space and really makes for a big difference. Oh, I scrolled the right way. Yes. Now, I mean, pardon me, come back. Scroll. We're going to use the keys. There we go. And we can be generating all the time, and now that we've got some entropy here, a little bit more than the number 1, it should certainly be a lot harder for us to collide on these numbers. So I've got some entropy now. Does anyone's entropy currently, or does anyone's seed currently start with 97FAB? Sweet. But again, it's still not necessarily strong enough. We still know, if you know that I'm using 3 dice, picking up 6 cards, and then looking roughly at my system entropy, we're not talking about a massive space to work with. So we want to do something. Let's add this true RNG. And again, this is like the Kleenex of hardware RNG, so don't worry about the name. But this is pretending to pump, and when I say pretending, I mean, please don't actually use this to generate keys. But this is pretending to, again, use this device, use the electrons jumping things at different intervals to create something actually random. So we're going to take that and we're going to concatenate it all together. So if we actually look right now at our entropy, this is what the entropy looked like before that was on. And again, we can see we got the 1, that was my dice roll. That was most people's dice roll. We got ace of spades, 2 of spades, 3 of spades. Really should have shuffled. And then we got our system details there. 81% CPU, 6% RAM, 0% network. So now we're going to generate this new key with TRNG, or with our random number generator. And now we've at least got some pretty good stuff going on. So we can start to feel a lot more comfortable about that. So if everyone's comfortable with our dice rolls, if everyone likes the fact that, or if everyone likes the deck that they've shuffled through and entered in, and we've got some TRNG going, well now, we can start looking at our private keys. So now, oh God, don't look. So here's the part of the process where we're going to back this up. So I'd like everyone to write down their private key on a piece of paper. No? So, years ago, we had to do that. And it sucked. Key ceremony used to be like 7 hours, people. And then it was always still wrong. So we learned that's not human friendly. So what we did was we took the seed, we converted that to the private key. This is specifically, I want to say BIP32, if you'd like to look that up. But again, just an awful format for humans. So luckily, what was created was the mnemonic stance. So we're going to take that same seed value, we took our entropy, we created a hash, and then we turned that to create the seed, and then we turned that seed into some words. So what I would like everyone to do is write down those words, or at least some of those words, pretend and humor me, and then we're going to throw them in our tamper-evident bag. Now, while you're writing down words, I'll chat a little bit about tamper-evident bags, because they're fun. So, again, tamper-evident bags, you can get them in clear. Clear isn't a great option for this process. It happens. These ones are absolutely massive, almost comically so. You can get normal-sized ones as well. I purchased the wrong ones, so if anyone would like to take extra, please feel free to come up and grab them. I would not like these in my home anymore. And you'll notice some details on them. This has a number, a little like serial number on it. That serial number is important because I purchased this on Amazon. These are supposed to be tamper-evident. It's supposed to be evidence that something was tampered with. If I take my backup and I put it in here and I rip this tape off, if I rip that tape off, I stick it on, and then I bury that somewhere. What have I done? I don't know what bag that was. Someone else is going to go buy comically large bags online, dig up my private key, copy it, put it in a new bag, and put it back in. So there can be things you can do here. Personally, I like taking a picture of the bag as record. When I really wish this tape would come off. There we go. I had to go the other way. So you tape it across, and theoretically, you should know if someone breaks that seal. But again, I like signing it. Give a little squiggly along there. It does help to try and get the air out, fold it up. Again, especially these obnoxiously long ones, or big ones that could be used as a giant balloon. Otherwise, you got this like thing this big sitting in your underwear drawer, and it's just like, this is absurd. But generally, you want to make sure that the whole point is when you come back to your private key, you know if someone has tampered with it. It is evident that it has been tampered with. And what happens if it has been tampered with? What should you probably do? Freak out. Good answer. Gentleman to the left here. Regenerate. Thank you. If you went to go dig this up or take it out of your underwear drawer or take it out of the safe at work and it has been tampered with, and there's any indication that it has been tampered with, your key is compromised. You need to immediately have a key ceremony in which you create a new key, create a new backup, do some test transactions, and then move along. Quickly moving those funds over before they're gone. Now, what should you not probably do with that old key? Anyone know? Don't use it. Excellent answer. Don't throw it away. We got to, perfect. You don't know. You might accidentally send money to that wallet. Some service might have an address stored in it or stored for it, and you might accidentally send some back over. Just because you're no longer using a key and you've migrated to a new key, you should always keep your old keys. Are these playing? Excellent. So, the next step, if we'd like to, I'm using CoPay on these screens. I believe they've migrated to an application called BitPay now, which is available for all the desktop operating systems, your phones, iOS, Android. So I'd highly recommend installing this app if you'd like to follow along. Because what we're doing on the right side is getting text messages during my damn recording. What we're doing is we're setting up a new testnet wallet. We're not going to deal with real Bitcoin today, because again, please don't actually use these keys for anything important. But we're going to take that mnemonic, we're going to create a new shared wallet, we're going to check off testnet mode, and then we're going to use that mnemonic that we built to put into the wallet and create a wallet with it. On the left side, on your right stage left, on the other side, we're going to do the same thing, but it's a little easier. Because eventually, once the person is set up on the left, you get your friend to scan the QR code that shows up, but also entering your mnemonic on the side. What we're doing is creating a multi-sig wallet. In this one, I happen to be choosing, you can kind of see there on the right, your left, geez, this is hard. You're choosing how many people you want to. So if you got 3 people at your table, you can definitely create a wallet across 3 of them. And you can say, okay, of these 3 people, we need all of us to agree, say 3 of 3. Or you can say, hey, we're going to have a wallet between us, and we're going to say anyone can spend, or maybe 2 out of the 3 of us can spend, and then create transactions together. Now, realistically, show of hands, how many people are doing this? Excellent, there's some. So I'm going to let this continue happening. And while I go through that, any questions so far? CoPay is not, BitPay is. BitPay Wallet, my apologies, BitPay Wallet. BitPay Wallet is CoPay. They've just decided, they built CoPay, and then they didn't brand it, and then they decided to brand it. I don't know. Are they vulnerable to X-ray? Interesting question. I would go with yes. It's certainly not preventing it. but those ones are large enough that you could probably fit like a lead bag in there too. So security is all about layers. Any other questions? Got some in the back there. Gentleman in the green hat. How do I go from entropy to the mnemonic? So how did I go from entropy to the mnemonic? On the screen, I touched it, and I clicked mnemonic. If the actual question was, in this application, what I'm doing is, again, I'm generating the entropy. So the entropy is just a concatenation of all these different pieces brought together. So it's just a big string of all our different details. I could throw my name in there. I could throw any other details in there that I think is going to help make this key unique. Then we take that entropy and we throw it through that hashing algorithm. And that hashing algorithm takes all of that content and gives us 256 bytes of unique data. As we've seen, it looks unique, but if we all have the exact same input, we can get the exact same output. But as long as we put something kind of odd and new into it, then we don't have that concern. And that's our goal, is to generate some entropy that after we put it through the hashing algorithm, we get a unique hash. Because for an attacker to go through every single one of those hashes is just not going to happen. So then we take that seed, and that seed is the hash, and we call the BIP39 library, which is the mnemonic library, and then we tell it to convert the seed into mnemonic, and then it displays it into a variable. I don't actually know the math that's going on behind that. Now, I will talk a little bit more about mnemonics, though, because they're a fun thing. One thing you'll notice about those mnemonics, the first 4 characters of every word is unique. And the point of that is because we're all really, I'm horrible at handwriting, and things get messed up sometimes. So the point of it is that each of those words, if you copied it down wrong, the words are designed in a way that you can hopefully figure out which word that is and kind of repair your backup in a way. So there's some kind of error checking involved in those words that help a lot in that case. Generally, there's big word lists. Some word lists are supported by some systems. There's one general one that gets used mostly. But there's nothing, you could just use your own word list as long as the client you use supported that. So sorry for not answering your question whatsoever. Next. Yeah. Well, no matter what, you're taking your entropy and putting it through the hashing algorithm. So you're always going to end up with 256 anyways. Again, how strong you want to be, that random number generator, that piece of hardware, that's going to throw a lot of data in there. So that's going to be like a really strong portion of that. But again, we don't want to ever just trust one thing. That system data is also actually going to be quite a bit of entropy in there as well. But again, we don't want to necessarily trust it because the inputs can be less unique than we hoped. And then the dice roll, we're not adding a huge amount of entropy in that dice roll, but it is a unique piece that we're kind of tacking on the front or end of it. So again, not really answering your question whatsoever as well. What a good one nonetheless. Just keep rolling dice until you can sleep at night. So everyone who wanted to do this, are those details slightly okay? If you want to follow along, and I'm taking this off the screen, the PowerPoint is on Shed with these videos in it, so you can download that and still follow along, or you can come harass me after or during. So I'm just going to carry on a little bit. If you've set up that wallet successfully, then you can go there and get some testnet coins from a faucet. Now, a faucet is just a system that's going to give out free coins. There used to be Bitcoin faucets. That doesn't really exist anymore. but they'll happily give out the coin that doesn't mean anything. Now, while you're kind of going or while you're going and getting those testnet coins to play around, I'll talk about kind of what to log. And now it is less important as an individual, although even as an individual, I think it's still important to keep track of what you're creating. I think there's also a certain attorney who may or may not be in the room anymore who would agree that keeping a record of each of your wallets is certainly important, and keeping that record separately from the wallets is equally important as well, because it's not necessarily as sensitive of data, but you might need it more often. Now, for an enterprise or an organization that's creating wallets, you might have to deal with your auditors, which might be a little bit more strict on what information you have to give them. So there's a lot of details, and again, it's going to change dependent on the organization. It's going to change dependent on what the purpose of these keys are. But I think there's some pretty basic stuff that you should probably be logging, like who actually was involved in the key ceremony. Maybe you want to leave it at their role, or maybe you want to specify the person. What day was this done? Now, one thing there, public key. When I create a private key, inherently I've also created a public key. And that public key is I can create addresses off it, so I don't have to have my private key available to create an address. The public key is just a mathematical pair of the private key. Now I'm just getting into Dirk's talk. You are all already there and already loved it, so I won't go too deep into that. But including the public key in that report of what was done is a very strong link back to the actual key that was created. If you ever have that key, and I swear it happens, people, and you're going through your files and you're like, what key is this for? And you have no idea. You don't know that it was Doge derivated off like some other random number, and you started the index at leet because you were being funny, and it made sense at the time, but you didn't log any of it down. But if you have that key and you create the public key, then you go, oh, I have the documentation where I said exactly what that key is and what my crazy plan was. Creating these things, you never think at the time, you're like, I'm never forgetting this. Forgetting it as soon as you said it. You're not going to remember. Writing things down is important. Writing down your process, writing down that you check the dice. Putting a mark off, I check the cards. Checking off that you checked the cards. Co-employee, checking off and saying, yes, I saw them check the cards. These are all checks and balances you can put into the process to, again, strengthen that key. It's not just about the entropy, it's about the process around it as well. That's why we call this a key ceremony, not, poker game. I don't know. Everyone who wants the faucet, QR code has got it, I assume. Excellent. Oh, that's fair. Well, if you want some test coin, I've got some extra here, so feel free to come up to me after the fact, and we'll make sure you've got some to play around, and we'll send some test transactions.
It doesn't like my address that I'm putting in.
Did you choose testnet?
Pretty sure I did, but I could have messed it up.
I blame the website.
Also, how would it know?
Bitcoin addresses are certain formats. Ethereum addresses, you can paste anything in there. It's going to be like, that's an Ethereum address, good work. Bitcoin addresses, every other currency has something called a checksum. So when you paste an address in there, there's a specific format it's looking for. Ethereum addresses are all just full of ponies and unicorns. So I don't know, that was a horrible idea. They were going to add that after. It just didn't happen. God. So, now, clean up. We've created these. We did our deck. We went through our deck of cards, and then we put the deck of cards in the box, and we threw it in the trash for the cleaning staff. Bit of a problem there? What have we done? We've just thrown half our entropy in the trash for someone to find. What can we do about that? Well, we can burn the cards. I don't mind the strategy. Colorado usually has a fire ban though, so they get upset about that. We can shuffle the cards. That might be a better option. So after we're done listing the cards, putting it into our entropy, maybe right there we just quickly start shuffling. Shuffling is very relaxing. Maybe you can be doing it the entire time. Make sure it's good. The dice, we're going to give those a couple quick rolls just to make sure we don't have anything going on. And then we're going to burn those too. Now, we all wrote down our private key. We wrote down our private key. We didn't write down that private key format because, yes, that is absurd now. Thank goodness for BIP 39. But we wrote down a note. How many spy movies have we seen, people? What's probably under that note? Anyone? What was it? Basically, I pressed pretty firmly. If I wrote down my mnemonic, I pretty much guaranteed if you rip that page off and get one of those pencils and just like shimmy it down, you're going to get my mnemonic. So what are we going to do, everyone? Burn it. Thank you. Not what I'm serious about. Like, get a can and burn it. Just save yourself. These are, like, I call this a key ceremony for a reason. There is pageantry to it, but there's reason for the pageantry. Question in the back.
Yes, so is there any best practices for using a cryptographic random number generator built into like a microcontroller or a USB device like true RNG? Like, should you just ask for a couple more keys or something like that to sort of clear out whatever was in there?
No, those should be fine. Those are always just giving a constant stream of whatever it's sensing. So I wouldn't worry about that too much, but the device it's plugged into could be a problem. Just because, let's say, okay, I booted up a computer and everything I did I'm pretty sure was in RAM. Now, everyone doesn't have to be necessarily technical. RAM is the thing where if you unplug your computer, gone. Your hard drive, on the other hand, if you write something to it, it's probably still there, most of the time. A little forensic secret, except for some new stuff. But even if I think, oh, well, that was just, I didn't tell it to write any files. I didn't say, hey, save my key to this file. But systems sometimes just write things to the hard drive just to like, oh, I'm busy over here, I'll just throw that there for now and save my memory space. It's called swapping. So it's possible that even if you don't think, when you're using this computer and entering in all your entropy, you don't think it wrote the entropy there. But let's take my little ceremony guide for an example. What do web browsers do all the time? They cache what's there. So it's possible that it's cached what I had onto the hard drive, so the next time I open it up, there we go, all my stuff is there. There's my key, great, that's good. So there's options. What can we do to the computer, everyone? Thank you. You also get an award. Come on up when you're ready. So, I got 2 minutes now. This is a recap. Pretty long. We're going to find a dark corner. We're going to verify our software. We're going to verify all our physical objects as well. We're going to judge our fellow employees and make sure that they're good. We're going to collect entropy from all these different sources. We're going to use multiple sources so that one of those sources doesn't bite us in the ass. We're going to hash those entropies together into a seed. That seed we can convert into a private key or public key, or we can convert it into a mnemonic for our own sanity. Then we're going to back that up, right? Back it up. Back up your keys. Please back up your keys. Please back up your keys. And we're probably going to put that in some sort of tamper-evident system so that we know if someone else has seen our keys when we've really not wanted them to. We can't stop them from seeing it. Someone can break into your home. Someone can break into a safe. We know that these things can happen. It's about knowing that it did happen. Then we're going to create a new wallet, or we're going to put that key on a server somewhere where it needs to operate as a hot wallet, or we're going to, maybe we don't even take that key and put it on a hardware device or a computer or any sort of object. It's possible that we just create this key and put it away. And every time we make sick gains on our trades, we just send them off to that wallet. We'll come back to it later. Then today we requested some coins from a faucet, sent them to that, or didn't because the website broke and it wasn't my fault. And then we tested transactions. And why do we test transactions? Because we constantly screw up as humans, especially when we've been working all day in conference rooms. And then finally, we clean up our mess, which I would love if everyone did, because that would really help me out. Time's up. That was well timed. Great.